Okay, wait one sec. I didn't mean to start the video yet. I wanted to graph these first. Okay, pause. Okay, that's better. Here they are. Sine and cosine. Forgot to label this one. Cosine. Okay, so sine is increasing. Make increasing green. Right here. It's increasing from 0 to pi over 2. Alright, and then it's decreasing from pi over 2 all the way until 3 pi over 2. See what's going down here? This function is decreasing, and then I did a poor job there. It should come all the way down to the minimum there. All right, but either way, it's decreasing from pi over 2 to 3 pi over 2. And then it's going to increase again from 3 pi over 2 until we stop this at 2 pi just because that's where we stopped our graph. So we're going to go from 3 pi over 2 to 2 pi. And then if we were to keep cycling through over and over and over again, we'd have different intervals, but we're just going to stop at 2 pi. All right? So then if we're trying to figure out why it makes sense that cosine is the derivative of sine, then we have to look down here at cosine. So here's cosine. Didn't mean to draw on it. Undo. Meant to point at it. Here it is. Cosine. Cosine is positive from 0 to pi over 2. And sine is increasing from 0 to pi over 2. So sine's derivative has to be positive up here. Okay, the derivative must be positive. Deriv must be positive if the function is increasing. So because cosine is positive right here, then it fits the mold to be the perfect derivative for sine. So let's keep going. Well, cosine is negative. It's negative from pi over 2 to 3 pi over 2. Oh, and sine is decreasing from pi over 2 to 3 pi over 2. So its derivative must be negative. Its deriv must be negative. And cosine is negative on that interval right there. So that makes sense that cosine then would be the derivative. And now let's finish it up. Sine is increasing from 3 pi over 2 to 2 pi. Okay, see how it's going up? It's increasing. 3 pi over 2 to 2 pi. Oh, and cosine is positive from 3 pi over 2 to 2 pi. The only other thing to check is there should be a derivative of 0 whenever there's a peak. So at pi over 2 and 3 pi over 2. And cosine is 0 at pi over 2 and 3 pi over 2. So then we can say that cosine is the derivative of sine. The one way of saying that is we say f of x equals sine of x. Then f prime x equals cosine of x. So the instantaneous rate of change of sine can be found by using cosine. That's the derivative. Okay, get ready because I'm about to erase everything and start over. So make sure you got this one. Okay, so I've redrawn them. Here they are. Now we're trying to figure out what the derivative of cosine is. So cosine is decreasing from 0. We should use red because it's decreasing from 0 all the way until pi. There, cosine is decreasing, so it's decreasing from 0 to pi, and then it's increasing from pi all the way to 2 pi. Okay, so it's increasing from pi to 2 pi. All right, well, the problem is sine is positive from 0 to pi, but cosine is decreasing. The derivative of cosine has to be negative from 0 to pi. Sine is not. It's increasing from pi to 2 pi, but sine is negative from pi to 2 pi. So it looks like we're exactly flipped, which is kind of a cheesy argument. Like there's more work to be done probably, but for this year, this unit, this time, it's okay to use reasoning to say, well, because sine is positive wherever cosine is decreasing, and negative wherever cosine is increasing, then the derivative that must just be sine flipped. So if f of x equals cosine x, f prime of x equals negative sine. So the derivative of cosine is just negative sine. And we can see that pretty easily by looking at the graphs and using a little reasoning. So in conclusion, the derivative of sine is cosine. We found that by looking at the graphs, and then we looked at the graphs again to find out the derivative of cosine
is negative sine.